Forces Revision Part 1, looking at a mind map to create a revision method for the forces topic. Today we're looking at Lesson 1, Scalar and Vector Quantities. So, Forces Part 1 starts in the middle of a large sheet of paper like this. Topics we're going to cover today spread out from that, scalar and vector quantities, followed by contact and non-contact forces. And then the other topic areas, which will be covered in later lessons, videos: gravity, resultant forces, work done, energy transfer, forces, and elasticity. Starting point is vectors and scalars. So what is a scalar? So again, carry on out from your title heading of the first lesson, scalars and vectors. Look in your book, identify what is the CGP revision guide, identify from the lesson the main points. So look at the headings: scalar, vectors, addition of vectors, and so on in the book. First point, what is a scalar? A scalar has magnitude or size only. Examples of a scalar: volume, such as 100 milliliters in a beaker; mass, such as a 2-kilogram mass; and speed, such as a car, which I haven't completed there. Let's put in the wheels. There you go. Going at 50 meters per second. What is a vector quantity? A vector quantity is a quantity which has magnitude, which is basically size, and an associated direction with it. So basically left, right, north, south, up, down. Examples of vector quantities: velocity, which is the vector equivalent of speed, which is, for example, something traveling at 50 meters per second, but this time in a direction to the west. Forces are vectors. So a 2-Newton force pushing to the right, which would be a different result than a 2-Newton force pushing or pulling to the left, such as open and closing a door. Moments, which is force at a angle, at right angles to the distance, so a turning force. Moments such as 5 newtons clockwise, the direction being clockwise that the object will turn. So if we add a scalar, it is just, since it's only got size, it is just adding numbers. So 2 kilograms plus 2 kilograms is 4 kilograms. If we're adding vector quantities, we have to take account of the direction. So addition of vectors, we could have a 2-Newton force plus a 2-Newton force, both moving to the right, gives us a total of 4 newtons. The size of the arrow indicates the size of the force in this case, or the vector quantity. If we have 2 newtons to the right, 2 newtons to the left, add those together, they're going in opposite directions, so basically it's 2 newtons minus 2 newtons. We say addition, but it's adding a negative. That will give you a resultant of 0 newtons. Next topic, contact and non-contact forces. So what is a contact force? A contact force is whenever objects are physically touching each other, okay? Such as somebody pushing against a wall. So examples of contact forces: friction, 2 forces, or 2 surfaces rather, rubbing against each other; air resistance, an object moving through air. You could also have water resistance, would be an object moving through a liquid. Tension, which is any pulling force. So you pull on a tug of war, you pull an object towards you, you physically have to make contact. The normal contact force, the normal meaning the right angles, and the contact force is any object when it's touching another object has the opposite reaction force. So you sitting down, the chair will push up against you. Then you have non-contact forces, such as magnets. So this is where there is not physical contact, so the objects are physically separated, there's a distance between them. Examples of this will be gravitational force, an object falling down; electrostatic force, so static electricity when you comb your hair, sometimes the hair flies away; and magnetic forces, such as the North Pole being attracted to the South Pole. Okay, that is the first lesson set up as a mind map. We'll look at other lessons next. Thank you.